Thanks, Alex, for the introduction, and today for having me. I owe you the explanation why we have such a cover for the banner of the event. So this presentation will be about churning, which means that leaving from being, for example, a specific customer or using a specific service. So here you can see a photo of our users group in Warsaw, people looking at left, I'm looking at right. And nowadays we can see a lot of movement where people start to actually joining data science webinar instead of those related to high detailed and advanced programming. So we have realized that move that people are eager to actually go to the data science meetup. So we started joining forces with European communities to have this joint webinar session. My talk will relate to the multi-state churn analysis. If you ever worked with a churn analysis, that you can know that this, in most cases, is a simple graph where you have an active and inactive client, or you have a patient that is alive or dead. In the multi-state scenario, there are many states where a customer or a patient goes through during his journey before, in the end, he churns or dies. So during the talk, I will try to explain churn as a marketing feature. From the other hand, the survival analysis, that is the baseline of the stuff that is happening under the hood, originates from clinical trials. So most of the tools, most of the workflows and applications can be explained in terms of clinical trials, biostatistics, which is my background. However, this has a very broad applications, for example, in marketing analytics. So as you might have heard, I ran Warsaw R user group with a lot of other people. I'm not the only one. I was an active R blogger. You could see a few of my last analysis on r/adhik.com website. And my personal goal for 2020 is the conference called whyr. You can check our website, whyr.pl, to see the remote conference that will be streamed on YouTube. On a daily basis, I work at Gradient Metrics. That's a crew of quantitative market researchers and technologists that actually help build robust statistical models that in the end help guide organizations through their most difficult decisions. We're data geeks, but word on the street is that we are easy to work and pretty fun too. So you can see that Gradient is an intersection of data science and traditional market research. Okay, so let's start talking. Let us start from the basics. The survival analysis, that is something that is at the baseline for the churn analysis. What is the definition and what are the examples? So this is a branch of statistics for analyzing the expected duration of time until one or more events to happen. So there can be more events that are analyzed. And what are those events? So for example, as I said, in the clinical trials, the most popular use case is a death of a patient. In other businesses, an event could be a deactivation of the service or an accident on the road. If you work in the insurance company, the device failure or an employee leaving the company. HR companies also are doing survival analysis, checking what's the estimated time a person will leave a company. Or today's topic, an event could be a customer canceling a subscription. So we know basic definitions and what questions it could answer, like if a client would ask you, okay, what's the purpose? What's the value of those analyses? Those are the questions it might answer in many cases. What's the probability an event will or will not occur after a specific period of time? What characteristics, which means features of a customer or features of a patient, actually indicates a reduced or increased risk of occurrence of an event? That's very cool, where you can find drivers actually make an impact on the decreased time to an event or increased. And also, we are able to find periods of time that are most or least exposed to the risk of an event. There are also many challenges that it faces. It's not like that you plug in the survival analysis package and then you just get results. As a data scientist, we all know that there are many challenges that are related in most cases to data and its format. So depending on the scenario, there are a lot of challenges for survival analysis. And the biggest one in this area of statistics is the censoring. This is the data that we don't have a full information about. And I will explain the censoring on the next slides with an example data. In most cases, this means that we have some information about the time where the patient was observed or a customer was observed, and we don't have more information for another follow-up time. Interval data, sometimes we just have an information about what happened with a customer in a specific period of time, but we don't have any information what happened before and after this interval. A few observations in the dataset may not be independent. That's in most cases a very crucial assumption of most statistical models, that you need to have independent observations. In this case, this might not be true. And also a huge challenge in the survival analysis are the time varying features, which means the amount that was spent on orders by a customer is a time varying feature, because during the time, customer makes more orders and the spend increases. Also, there are challenges related to events. We might analyze different various scenarios for events. For example, there are recurring events. If you analyze the time until the next order, and multiple orders might happen, then each order is a recurring event. From another hand, there also can be a challenge of competing risks, which is the case where a patient in a clinical trial can pass away from multiple reasons, not just one. And there's also a multi-state nature of the process. That's the challenge that we will describe today, where there isn't a single transition from active to inactive client or from alive and that patient, but there are multiple steps on the transition, on the flow, before it actually reaches the churn state. Alrighty, so this is an example of how you get the data, how you observe events. So this is the view of a data structure. And if you look at the client's history in an online shop, you can imagine that they didn't start their history at the very same day. Each of them started the history at their first order, and they could actually register out of the shop at their time, and they could still be an active client. So this is just an example, but imagine this is a clinical trial, and also patients are added to the clinical trial in their specific times, and we observe them at the follow-up time and at a specific period. We know that they either had an event, passed away, or they just dropped from the clinical trial. And there are multiple reasons. They could just move away. They could just have a conflict with a doctor, and they just dropped the clinical trial because they no longer want to contact their doctor, or they stopped appearing on meetings. So we know that they were alive for a specific period of time, and then they just disappeared from the clinical trial, but they didn't die. So this is the challenge in the survival analysis, where you observe the customer, where you observe the patient, and then you have an information that even happened, or there happened a censoring. And the censoring is a moment where we actually have no more information. And for the customer analytics, you have a database snapshot. There were clients active till that time, and then we no longer know whether they churned or not, because that's the end of our story. And that's where the censoring happens for customer analytics. Yeah, so how you deal with the data? Well, you need to find a trade-off, some simplification. So you abandon the calendar time. You start counting days in which the customer was observed in the study, and you have all the customers that start from the same starting point. Maybe let me get my microphone to be a little bit more sensitive. All right, I hope that helps. Yeah, I just got a hint that my mic wasn't the best, so I tried to change that. No other information whether that helped. So I tried to speak louder. So that's the data structure that you observe. So in the simple case where you have one event, whether the patient died or not, or whether it was a censoring, or whether a customer is still an active customer, you just start from the point 0. That's the first day when the customer was observed, and then you have a follow-up information whether this is still an active client or not. And we've got a basic tool for a survival analysis. This is called survival curve. There is a statistical method that provides an estimate. This is the Kaplan-Meier method, and we've got a formula. And we've got a formula here. So we've got a formula here. So this presents the probability of the fact that a customer or a patient are still alive. So on the x-axis, you see the time. On y-axis, you see the probability. And this is just an example plot where you have a distinction to females and males. And from that plot, you could see that there's a line with confidence intervals for females and males in a specific trial, and that displays that the probability of survival is higher for females. There can be a special statistical test called log-rank applied to this data. That would let you know that actually females have better prognosis than males in this specific trial. This is just a plot. You can also have a look at the table, the number of survivors at a specific time. So at day 0, we have almost more than 200 patients, and then over time they keep dropping. So you can see that after 400 days, there's just not enough patients to have any inference. And at the day 750, there's just really few. So keep in mind that also the size of the sample is getting reduced over the time. So you should have a very caution inference. What models could we actually analyze? What are the multi-state models? So you can have an alive and a dead model. That's the simplest model, where you have where you have just one transition, and also you can have multiple transitions at the same time, where a customer can move to another state. And let's say at the survival analysis clinical trials terminology, you could be alive, you could be ill and dead, or you can have on a graph that is below deaths from multiple reasons, or you can have a multi-state flow where you can be alive, ill, severely ill, or you can you can die. So how does this data structure looks like for a multi-state case? You have a time and then and a specification whether then the event appear. So you have 3 types of events. For each of them, you would have a flag whether this appeared or not, and what was the time of an event. So you can see that many customers have various events at very specific times, and the last one is the censoring. All right, let's move on. Let's get to some use cases. So in typical applications, very popular statistical model that is used is called Cox proportional hazards model. Let me just explain it very briefly. When you have one event, which means there's just a simple transition from being alive to dead, or from being a customer to being a churned customer. So here you have few assumptions. We assume that proportions of hazards, there exists a proportion of hazards, which means if we look at groups, one group has the proportional hazard, which is the occurrence of the event during the specific time, proportional to the other group. So if we look at the groups divided by the sex, males and females, males would be proportionally more exposed to the risk or less exposed. The model will specify. Also, there are some other assumptions that continuous variables needs to get into specific continuous form. Observation needs to be independent, and you cannot have an information between the censoring and the actual mechanism that rules the times where the people are observed. And if you look at the example coefficients, you have the variables put in the model. This is the result from our model. You have the age, you have some other statistics called ESOC, PS, and RX. You get the coefficients, and to interpret them, you take the exponential function over the coefficient, and you get the multiplication. So there is some baseline level for RX and ECOG PS. And if you increase this variable, you need to multiply the hazard by this value. So multiplication smaller than 1 means the hazard gets reduced, and higher than 1 means the hazard gets increased. When the hazard gets increased, you get more exposed. And also, there's a special subminer package that allows you to check some assumptions of the model. Alrighty, so let's get to the Endstate model. So we know that we will use Cox model. We know how to apply it for the simple case when there was one state. But imagine a lifetime of a customer that starts with a subscription. That it's a subscription at an online shop. The customer starts with a card that has a lot of products in it, and that's the state. One user with multiple products, that's the yellow state. And from this state, a user can delay his subscription. It's not happening the same amount of time, like every month or every 6 months, but from time to time, a user keeps delaying the subscription. So something is happening with this user, and he's in the other state. That's closer to churn. Or have a look at the green one, user left with one product. So he had a lot of products in his cart, and at some point he kept dropping. He doesn't longer need all those products that he ordered in his subscription, and then he's just left with one product. And also state 4, the first blue bar, user can have already made a delay and be left with one product, so he's really probably close to the churn. And then there's last state, 5th state, churn, when client completely delayed his subscription. So we can see numbers on nodes, and we can also see numbers on transitions. So there are nodes, which are states, and transitions, arrows that represent the model in a specific transition. So we could go from state 1, user with multiple products, to actual churn, and that would be transition 3. And for example, we can go from user left with one product, that's state 3, to state 5 churn, that's transition 7. So we would like to get an information for every possible transition. And for that, we specify the transition matrix. There is a from state, then there is a to state, and we have numbered states and the name of the transition, which is also numbered. And we have seen on a previous example for a Cox model that we were able to get coefficients for a specific model for a one-state scenario. So this is the MultiState model where you get coefficients for each of the transitions. So transition 1 was from state 1 to 2. Transition 2 was from state transition 2 was from state 1 to 3. And for each of the transitions, we get coefficients. And those are the coefficients for the variables that we use. We have used age that had a lot of levels, more than 40, middle-aged client, and we have a reference level. Most regression levels have the reference level that you take as a baseline, and then you use the coefficient, to actually calculate the difference with the base level. We also use a discount for whether a client ever got a discount or not. What's the gender and what's the year of the registration, and those are the coefficients. If they are smaller than 0, then in comparison to the baseline level, the risk gets reduced. If they are higher than 0, the risk gets increased, and you are more probable to actually get to move on a specific transition. And the table wouldn't be a stuff that you actually present to the client. You would get it to actually create the plots. And let's compare two various clients, customer A and B, with a discount, without, the gender and the male. There's different age, and they join at different times. And you can create the plots on their lifetime and the probability in which state they are. And we can see that from the bottom to top, we have those states that this is the best client. Then the client starts reducing his card, start delaying, the subscription is almost at the end, and then the red is the actual churn. So now we see the customer B has really high probability over the time that it will get churn at specific points. So we know that we should actually start target males that didn't ever get a discount to actually to prevent them from the churn. And there are a few notes at the end that I have. So you should know that you should check model assumptions at every possible transition. There are some varying variables that could be taken into the model. I just present the stable coefficients, but happy to talk after how this could be actually used in the model. And for cyclic models, you could use Markov chain. This was the presentation where I presented the acyclic model when one of the states is the end state and you cannot go back. And I'm almost at the end. Some credits, the plots and analysis was made with the sort of minor package that can be checked on our archive. And if you like the talk, then please feel invited to the whyr conference that will happen at the end of September. We will stream on YouTube, and you can register on our website, which is whyr.pl/2020. And if you like the talk, also you can have a look at codes and slides at github.com/g60/mchurn. And I think that's all for now. I hope we have some questions that I can answer during the Q&A session. And thanks for listening and giving my voice to Alex for now.